Hey, thank you for tuning in. So in this video, I'll showcase how you can decrypt DPAPI secrets without triggering anti-malware solutions and potential escalator privileges within the Windows environment. I'll show two methods. First one is more manual, where we got a shell in the system and can pull or download files from it to our box, calling this instance, and to decrypt the secrets. And the second method is more automated using a Python tool, but it does require you to have local admin rights on the system, so it won't always work. Let's just start off with a quick overview of what DPAPI is. So DPAPI is Windows Data Protection API. It provides a simple way to encrypt and decrypt data using cryptographic keys tied to a specific user or system. Basically think of it as a private key that was created using the user's password. This allows applications to protect user data without dealing with complex key management. Many applications use DPAPI, including Chrome cookies, login data, Windows Credential Manager, and Vault, Remote Desktop Connection Manager. Those are .rdg files. At a high level, DPAPI encryption for user-specific data relies on private key, or also called master key. As I mentioned, it's derived from the user's password. These keys are stored in the following locations. I just have a VS Code here to showcase. So we have C users, username, update, OMIN, Microsoft Protect, user SID, which is a unique identifier, and it's going to be a random with just a random file name. Or it could be under local Microsoft Protect. So a user obviously can have multiple master keys, and to decrypt them we need either the user's password, we'll focus on that later, or the main backup key. We'll focus on the user's password in this video, but maybe later I'll do one for the main backup key. And second part is encrypted data blobs. So these are the actual data blobs that store credentials encrypted with the master key, and those are usually located at this location. So C users, username, update their own Microsoft credentials, and it's just going to be a random file name. So these are the locations we should look at. And just to summarize, to decrypt a user encrypted data blob, which is this file, will have our credentials potentially. We'll need to decrypt master key first using user's password. So we need to have user's password in advance. I'll also link a few good articles if you want to know more, and you can check it out. So yeah, to the demo, I'm gonna showcase. So here I have a simple Active Directory environment with the main controller and an up-to-date Windows 11. So I'll just log in real quick. So as you can see, we're just a regular user, no specific permissions, nothing. And we have a Windows anti-malware protection enabled, so all is up. And I also have my CalVM. So let's pretend we're able to compromise this user. Fcastle, because had a bad password, for example, and let's pretend that we're able to get a shell on the system. When I'm on RDP, I'll just be on the system, but let's pretend that we're able to get access. So we'll look for the packets, because it's a good place to start when you're looking to escalate your privileges. So yeah, let's start by going to the directory I showed you before. That would be C users, R user, update, Roman, Microsoft Protect. Oops. So, and here we have a SID. So we go to this directory. You can also take a note of this SID. It's gonna be useful later, so we can just go back to our notes and save it. We'll need to decrypt the DPAPI master key. So here we have to use either ls-fo to show hidden files, or either course will also work because it shows hidden files. So yeah, these are master keys. What we do right now is we'll use cool tool called certitude to base64 encode those and copy the data to our Kali VM. So I'm just gonna showcase this. So here we can see also that we have 3 master keys, so we'll need all those because we don't know which one will work for our set of credentials. Let's also look at the credentials real quick. So this will be under CD users update time. Oh, sorry, password update time. Again, Roman, and it's going to be under Microsoft credentials, as you can see in this file. So credentials. This will be the actual encrypted data blobs. So let's take a look. We have any, and do slash program, and yeah, we have a data blob. So that's interesting. Let's get the data blob first. So here's the command: cert detail. If I can type code, paste in the file name, and it needs input file and output files. You can do the same, just .base64, base64. So now we can look at this file. So here we get the data in base64 encoded form. It's just easier to copy this data to our Kali box because Windows handles base64 encoding differently, and if you just save it, you'd have to use specific commands to decode on Windows on Linux. Sorry. And here we just go to our Kali box, create a few directories. Here we got keys and secrets. I'll go into secrets because it's data, and create a file credits.base64, paste it in, and let's decode it using base64-d command. And let's just output it to credentials file. Oops. Credentials. Here we go. Now we have the encrypted blob here, so we'll need to use it later. Let's go back to the Windows box and get all the master keys. So I'm just on and go to protect. Oops. Let's go to our suite and let's do this .com. And we're gonna do the same base64 command for all these 3 master keys because we know which one we're gonna use. Let's type again certitude dash encode, name of the file, and destination. Let's get the base64 again, so we can do the same. Let's actually copy the name as well, so we could save it in our Kali box. Here I also have a directory called keys, so let's clean that up. And create a new file. Clipboard. So we'll just use the name of the master key for this. And paste in our base64. We'll do decoding later because we have quite a few master keys. So you get the process. I'll just pause the video real quick and copy other master keys, and I'll resume here after I got all the files. Okay, now I got all the master keys and all the data blobs, and I got them all base64 decoded. I'll show you using base64 command, just get file and base64 output, base64-d and output. So right now we're gonna use Impacket DPAPI.py to decrypt master keys using the user's password. The password we have in this case is just password 1. So I'll just make sure we're a standard user using netexec, just a tool. So we'll do smb user fcastle and it's the password. So yeah, we're just regular user. We can connect to the box, no special privileges, nothing. So let's try to decrypt the master key. So the syntax goes like this: DPAPI-protected, now specified one master key. Now specify dash file. Specify one of the master keys here, the one that we base64 decoded. So I'll go just with the first one. And we'll do dash seed and use the seed we saved. And we do dash password. And the password is password 1, where we password for the user, but it's just a demo. There we go. And we got a master key, so this is what it looks like. Let's just save it. It's one of the first. It's one of the master keys. We got 3 of those, remember? So I'll just put in our notes. Because we don't know which one is gonna work, we can save all of them and try them all. Let's do the same one for the same master key we pulled from the system. That's 82. Now we do it for C4. And we got another key. In here. And let's do it for the third one. It's gonna be F45, this one. And here's our third master key, so let's do this one as well. Save it or VS Code notes. Alright, so next step is gonna be to decrypt the actual data blob. Go to that directory. Secrets. So here we have our credentials that are stored in the data blob. So the syntax is gonna be a bit different. So now we do DPAPI credential, specify our file, name credentials in our case, and specify our key. Because we don't know which one, let's try them one by one and let's see which one works. So I'll copy the first one, paste it in. And the first one actually worked. So we got our credential manager password for Castle admin. And this is a different user and we got the password. So we can try to see if it works. Let's do SMB, sorry, NXC. SMB. And let's start our new user. And the password. And we get pwned. So this user is actually a local admin on the system. This seems to be a common problem because our user fcastle is a regular user, but this user also has an admin account /ADM, and he was using the credential manager to store credentials for his admin account. We were able to decrypt it, and as you can see, it's a really secure password. And now we got local admin on the box. Let's also see if we have any rights for the Active Directory itself. So remember which IP I have set for the domain controller, but let's do /24. Yeah, it's doesn't have any rights on the domain, but it is a local admin on the box, so we can dump credentials, we're able to escalate our privileges, which is fantastic. And last part, let me just showcase a DonPAPI, a tool. So right here. So this will help us automate secrets dump remotely on multiple Windows computers, but of course with defense and evasion in mind. Oops. So you can look at this if you just Google DonPAPI GitHub, you should see it. It's from who's the creator, login security. And you can see all the switches in here. It does require local admin rights to run. So for example, if fcast ADM had some DPAPI secrets for another user, we can run it like this. So I'll just show. So yeah, here you have different arguments. So usually you go like this. Then specify user and password. And HTTP for target. You can specify a subnet or just one machine. If a user is local admin on multiple machines, to dump DPAPI secrets from multiple devices, which is very handy. So here we'll just specify our target machine, which is Punisher. Oh, that looked out. And specify the IP, and now it's -149. And if the user has any DPAPI secrets in there, it will pull those. So let's see. So the able to dump LSA because we're local admin. Of course, it does that. This tool might trigger anti-malware alerts, so you have to be careful with that. There's certain switches you have to specify because they're different collectors, and some of these are more noisy. But if you go in like Firefox or VNC or Wi-Fi, it's gonna be less noisy and will bypass anti-malware. So yeah, it's gonna take a second round, but you get the idea. Thank you for watching, and I hope I'll see you next time. Bye.